Hello. So I'm going to run through some SQL, and in fact, there's also on the website for the course, there's going to be a huge knitr file that covers everything I'm going to do right now. So I'm not going to do views. I'm not going to create tables, which are about the two other interesting things you might want to do. Setting security and rollbacks and stuff. All I'm going to do is cover select commands. So let's first read in some data. So here's two CSV files, one with crashes and one with roads listed. Let's take a look at them. Okay, this one has for each year, each road, number of crashes, and that must be a volume of traffic estimate. Okay. You'll notice the road is a string. Yeah. And we also have the command, the database roads, which is also a data frame. Let's look at that. So that one, for each of the 5 different roads, lists what districts it's in and how long it is. So we're going to use that occasionally. So let's just run through a few of the commands. I'm thinking of starting up SQLdf. Oops. Let me try that again. Starting SQLdf, there it is. Okay, now let's do the very simplest select command. I'll explain it in just a second. Before I hit return, it has a select. I'm saying what variables I want to select out of the database: year, number of crashes, and volume. Here's where the database is from. So from select tells me what variables I want in this table I'm creating. From is where to get it from, and this filters it. So only things with year greater than 2010. Let's see what happens. There we go. We've got the years above 2010, number of crashes, and volume. Pretty simple, huh? By the way, I could store that pretty easily. Let's see, hold equals if I wanted to. Let's look at that. So there we go. I'll bet that's a data frame. So I could process that any way I want once I've extracted it. Okay. Now let's get a little fancier. Here's kind of like the head command again. If I do this, we'll get the same thing. We're selecting year, number of crashes, these 3 columns. This is the database we're getting it from, where year is greater than 2010, and I say I only want 5 things. This is very database dependent, by the way. So, a warning there. Oops. Holy smokes, it really is. What happened there? Let me just type it straight in. I'll put double quotes around it. Why not? Year, number of crashes, volume are what we want in the data set. Oops. I just want to hit return. The select is followed by a from. I say what data. And by the way, that's all I really need. But if I want to filter it, year greater than 2010, and I'll do a limit 5 just to see 5 of them only. Okay, that's going to have to be pretty exciting, huh? Okay, I'm so amazed it worked, I probably should quit while I'm ahead. Another command is order, which is simple enough to do. If you want your from. Now, by the way, I'm leaving off much of the cool stuff, which is creating tables, creating views, and also which allows you to set conditions on each of the columns, and security, and rollbacks, which means that means if you make a bunch of changes at once and some of them don't work, it rolls it back so that it won't cause damaged databases. And there's even what did I forget to mention? Yeah, good enough for now. But we're just going to stick selects for now. Oh, and you can also index variables if you do a lot of searching or sorting on using a specific variable. For instance, in your wheres, and you have lots and lots and lots of data, you can index them, which creates a tree, binary tree, which allows for much faster sorting. So it's kind of optimized. Let's go where year is greater than 2010. And you can order by. And this could actually be set to ascending or descending, but I'll just do the default. There we go. There's ascending. Let's see if we can get something slightly more interesting. Here's something. There's a slight teeny-weeny change you can do on the on that. Is by using distinct, select distinct, it only allows each road to appear one time. So select distinct roads from crashes. Goes in there, it takes roads, but you only get one of each. Now where you can do lots and lots and lots of math. So let's look at this is actually has a completely silly and superfluous line in it, but that's okay. Let me just type it. SQLdf. So let's say we're going to plunder some data. So we'll select everything. This means all the variables from, so that's wildcard from the crashes data set. Where year, now there's an in where you can put a list of things, there's a between where you put a lower and upper bound. And you can do all sorts of nesting with parentheses and logical. So I'll say things where the years between 1998 and 2000 and not, this is the superfluous one, road is null. That's actually the missing value command. So hopefully I balanced the, oh, there we go. So the year is going to be between 1998 and 2000, and there's no missing roads. Of course, there weren't any missing roads in the data set, so this and doesn't really do anything, but it could if you had missing data. And you have ORs. You kind of get the idea. You can select year, road, and crashes. From crashes. Where? It's going to get boring real fast. Less than 1994 or year greater than 2010. Actually, I could have done that by using a not and then a between. So not between the two, but order by year. There it is. Exciting, huh? Less than 1994 or greater than 2010. Those three variables. Okay. Oh, here's an in command. This is also handy too when you have a list of things. It comes in even more handy soon. Year. Let's get year, road, in, crashes again. Oh, I can do volume also. Why not? From crashes. Guess what? We're going to do a where to filter it. where year is in, and then we put a range. No, not a range. If it was a range, it'd be between. In, you put a list of things. 1995, 1997, and 2000. Okay. Ordered by year. There it is. Okay, let's do some wildcard searches. The like command. This is especially good for strings. So let's say I want, now how do these work, by the way? So they can get really fancy. They can do regular expressions. But in general, what you do is you put inside single quotes. Remember, a percent sign means 0 to as many characters as you want, padding there. An actual value means there's going to be a U there. Underscore means there's a single character of any kind. So what this would do is any amount of characters followed by a U and then 2 more characters would match this. Okay. For instance, so we can go a long ways with that, searching strings. So let's do select everything, wildcard from crashes. Where road is like. Okay, what this is going to do is it means it'll start with I, have bunches of padding, and then end with a 5. And year greater than 2005. So it's a rather primitive text, but with a bunch of and statements you can get kind of fancy with it. Let's look. There we go. Interstate, they start with I and end with 5, all of these roads. And then we have all the variables, yep, after 2005. So you can see select is really the workhorse here. Eek. Now, gosh, calculated fields. You can actually create some calculations, and we're going to get a little fancy here, but what you basically have is, in the top, if you want to create a new variable, let's do a really simple one. Select year minus 2000 as indexed year, and then we'll put road. Okay, that should be a created variable there. I'll see if that actually works. Oops, my quotes here. And let's go from, I could be risking this, from crashes, and I'll just have that be that. Okay, there we go. We've created a new variable. It's essentially, you can put as many variables as you want. You just do math on the variables. You say and to name them, and so that's indexed year now. So I'm having this index year variable and road variable. So you have a bunch of, by the way, when you look at the handout that goes with this, which will be in the materials, the course materials, this mouse here is going to be the curse of me. But okay, let me do one that's a little faster where I'm going to cast things. So here, sometimes a variable is an integer, and here's the problem. If you take integers and divide an integer by integer, you might get rounding. So integer problem. So I'm going to use cast. The command cast is used to convert one type of variable to another. So I'll select year and road, but then I'm going to create a new variable. So I'm still writing down the variables of my thing, but I'm going to go to the next line just because it's taking up room. I would take number of crashes divided by volume, but I worry that they're integers. So what I'm going to do is cast them. Cast number of crashes. And there's a convert that thing. You can change things from strings back away from strings. So as float. So I'm casting n crashes is going to become a floating point variable. and it's going to be divided by volume, which is going to be a floating point variable. So there's a little, the typing is a little bit more picky in SQL than it is in R. So I want to make integers into, and then I want to name this variable. So notice I've created a data set with a column year, column row. Those came straight out of the original data set. But now I'm taking this fraction and I want to give it a name. So all of this is going to be called relative risk. Okay. Then I have to say, now those are my list of variables in my new table. I have to say where they come from. I'm going to filter them a bit. And what the heck, I'll even order by relative risk. Why not? Okay, let's see what happens. Woohoo! Okay, look, there's the relative risk that's been calculated. There's the year. It's an order of relative risk. Okay. Now, sometimes you want to make subtable, like group together things and aggregate them, not aggravate. That's me. Then my job is to aggravate. It's aggregate. So, aggregation is very, very easy. You just say your regular select, but then when you create the variable, you use an aggregating command like sum, average, maximum, max, min, things like that. Count are things that clearly work on a list of values. So if I say sum of n crashes, from the database crashes, and again, this SQLdf is making me put the select statement inside quotes, but in general, if you were doing SQL, you would actually enter this command right here, okay, without the quotes around it. So let's see what we get. Let's think what's going to happen. I'm just saying everything aggregates. There's going to be one sum. Oh, I could name that better. Let's give it a better name. How do I do that? As big sum. Let's see if that works. There we go. So I can name things if I want using the as, remember. Well, that's kind of not too exciting. Ooh, you know, I could divide things by sum of n crashes, but I won't. Instead, I'm going to do a little fancier. Go on fancier and fancier aggregation. So now let's aggregate it by year so that I get the sum for each year, each individual year. So I'm going to have sum of n. Well, let's give that a name. Let's call it big sum. Why not? Okay, it's from crashes. Yeah. And now how does it know how to aggregate? Because I'm going to use group by year. And doing that is going to cause it to group each year and give me the sum of crashes in each one of the years. Okay. Now, this can be filtered in a couple of different ways. It turns out if you use a where statement, you filter the table before you do the aggregation. If you do a having statement, you do it after the aggregation. So let's say we just want rows that start with or have the int in them, but we want a sum per year. Did I do that right? Yeah. Some n crash. I'm going to give it a name. Year sum. Crash sum. How about that? Okay. Where is it from? Look at that. It's going to be from crashes. Now, before it hits anything, I'm going to filter it. So I want roads that are like blah 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 followed by int. The reason I'm putting some beginning blah 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 is there could be white space at the beginning of those names. So all the interstates I'm going to filter. And then there's going to be a certain amount of, so this just has capital I and little nt in it somewhere. And then I say group by year. There we go. So look at this. We filtered it so we only get the interstates. And then for each year we're going to get the sum over the year. Now to kick some of those things out, we use a command called having. So let me try having. Group by year, but then you go having, so that'll take afterwards year greater than 2000. Okay, so that will only keep the aggregates that have years bigger than 2000. Actually, even more interesting might be having crash sum bigger than 200. That would be, so that's gonna, that filters the aggregated data that's been summed up. So let's see what happens when I do that. Oh, there we go. Only crashes that have, their crash sum was more than 200. Here's the years and the road. Of course, it's only roads that are interstates. Yeah. Yippity yip, 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 yip. Ah! You know, no, I won't even say it. Now, here's the thing. You can always slip a select statement anywhere you have a table. So look up here. So you could, where you say from, you could slip a select right here, or you could just create a new table and then give it a name and then use it right there. But you can pre-filter a table, put it there. You can use criterion the wheres using a new table. So there's lots of places where you can use a select command nested inside a select command. Basically what it does is it creates a list of values, or it creates a table of values, and then you just process them just like a regular list or a regular table. So list of values. So for instance, let's look. I want to take road, year, and volume. Why not? From, let's go crashes. But now I want where, and I think to myself, where the volume is less than or equal to the, let's say, average volume of all of them. Let's say, even cooler, 1.5 times the average volume. Well, how do I do that? Well, I need a select statement right here in order to aggregate and figure out what the average volume is. So I'm saying volume is less than, and I put a nested select. I'm going to have a single variable in there. It's 1.5 times average volume. I could even give it a name. Should have. I've got a name. I've got a name. Crashes. From crashes. And then where year is greater than 2000. So what's going to happen here? Well, first it does the innermost of the selects. So it's going to go there and say, oh, I'm going to create a new variable. 1.5 times the average volume. I don't have a group by. So it's going to take the average volume of all the roads and everything where the year was greater than 2000. So it's going to take all the roads where years greater than past 2000, average them all. You'll get one number here. I could add a list, but in this case I'm just getting one number. I'm multiplying it by 1.5. And then that gets used in this outerware statement. So outerware, as opposed to underwear? I guess so. Select road, year, and volume from crashes where volume, so now I'm going to select the years and roads where the traffic volume is more than 1.5 times the average traffic volume since 2000. Does it work? Let's hope. Oh, okay. I didn't nest the right number of parentheses. From average volume. Oh. No. Huh. Okay, I gotta try this again. I put the wrong number of parentheses. Select road, year, and volume. Okay, that's my select. From crashes. That looks good. Where volume is less than or equal to select 1.5 times average volume from crashes. Huh. I should have the viewers call in and tell me what I'm doing wrong. Where year is greater than 2000. Okay, so that's all in the select statement. And so that should all be, oops. Oh, there we go, good. I said to be careful. Yoicks. So again, it's every combination of road and year that has volume above 1.5 times the average volume. Wonder what that is. I can take a fast peek and see what that is. LDF. Nah, I won't give it a name. So I'm going to select that. Select that. And I'll go where year is more than 2000. Oops. Okay. So 95,113. Okay, less than or equal to 95,113. It's probably a pretty high number. Just not probably kicking out many values. Okay, I could have counted them actually too. But I won't. So select. So up here I could put counts of things if I want. All right. So just to end this in a reasonable amount of time, I'll do a join. This is when you merge two data sets, and a join is very simple. Okay, let's look at our two data sets. Crashes. There we are. Crashes shows combinations of road and year with some information. Roads has information about each one of those roads. There's only 5 things in there. So when I do a join, which is an inner join, what it's going to do is do something totally insane. It's going to take everything from this data set, which is pretty big. I mean, it's not huge. It's 140 or 50 things, rows. But it's going to combine every possible combination of these and these, which is definitely just not what you want. So actually, I'll do one of those. SQLDF. This is if you're not paying any attention. Select. Okay, so let's do some variables out of here. We'll get year. Oh, crashes. Dot year. Crashes. Notice I have to say which database they come from in case they have the same name. If there's ambiguity, if there's the same name. So road definitely is a problem. Probably can get away with the rest of them just being left alone because there's no ambiguity. So length. In crashes. Volume. Oh, what the heck. I'm just going to go for it and put a star. Everything. I want everything. From, and now I put the two databases. Crashes. Join. I could just say crashes, comma, and the other one also. So it depends on what style you're doing. So what that's going to do is combine every pair of these. And if that's all I do, I could be in deep, deep trouble. Let's look. Whoa! So what do we get? We got too much. So look. Every combination of year, road, end crashes, volume, road. Notice even ones that shouldn't even match. They're different roads, and they're different roads in years. So yeah. We might want to weed that down. And how you do that is with the where statement. So let's go see what we want. So let's say I really only want them to match up when it's the same road in both things. And that should do exactly what I want, because it's going to pair up for everyone my crash data. There'll be a road listed. Then I'll get the road information from the other data set and pair it together. So I'll do the where. And then crashes. Gotta be careful here. Road equals roads. Is it roads? This should do it. Okay. Much, much less output. So now I've kind of merged the two. So here's from I have the year, the road, end crashes, and volume. That's from the crashes data set. And then I have matching it, the road, along with its district and length from the other data sets. So these have all been paired together. And of course I can stick all the extra things in where statement I ever want to stick in. So let's go. For instance, I can say, by the way, year equal year won't do anything because there isn't a year in the roads file. I could say it has to be this and year greater than 2000. That works. Okay. And I think that does it for now. So go try it out. Go on some websites that don't, infect your computer. There's a million little game websites online that allow you to practice your select statements. Since the select statements are what you use to get data, that's the main thing you're going to use. So we may come back to this a little later, but that's it for now. Okay. Thank you.